Hello everyone. In this video, we'll learn about harmonic analysis. Now let me describe about harmonic analysis. Harmonic analysis is a mathematical procedure for describing and analyzing phenomena of a periodically recurrent nature. Many complex problems have been reduced to manageable terms by the technique of breaking complicated mathematical curves into sum of comparatively simple components. Now let me recite an example. In music, if a note has frequency f, integer multiples of that frequencies are 2f, 3f, 4f and so on. These are termed as harmonics. As a result, the mathematical study of overlapping waves are called as harmonic analysis. Harmonic analysis is a diverse field including such branches as Fourier series, isospectral manifolds. Isospectral manifold means hearing the shape of a drum, and topological groups, signal processing, medical imaging and quantum mechanics are three of the fields that use harmonic analysis extensively. Now let's know more about harmonic analysis in detail. The Fourier series of a known function f of x in a given interval is got by finding the Fourier coefficients. Mathematical procedure for describing and analyzing phenomena of a periodical recurrent nature, which I have already explained. Harmonic analysis is the process of finding the Fourier coefficients numerically. So here we need to find the Fourier coefficients in a numerical way. To derive the relevant formula for Fourier coefficients in harmonic analysis, we employ the following result. The mean value of a continuous function f of x over the interval 0 to pi, denoted by f of x and defined by f of x equals 1 by 2 pi integral 0 to 2 pi f of x dx. Now how to calculate all the values a0, a1, a2, etc. b1, b2 using the numerical formula. So here you need to calculate numerically, and a0 is 2 summation y by n. You have to add all the values of y. a1 2 times summation y cos x by n. So you need to calculate cos x, y cos x, then sum of y cos x and divided by n. a2 value, calculate cos 2x, y cos 2x. So we'll be getting y cos 2x value, sum of those values together. Like that, you have to calculate a1, a2, a3, b1, b2, etc. Thus, what is f of x? a0 by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x plus etc. Now, there are terms called first harmonics, second harmonics, third harmonics, etc. Now, how will you calculate first harmonic? First harmonic is written as a1 cos x plus b1 sin x. So, if you need to calculate second harmonics, you have to get a2 cos 2x plus b2 sin 2x. Now, how about third harmonics? Third harmonics will be a3 cos 3x plus b3 sin 3x and so on. Now, if you want to calculate the amplitude of first harmonics, you have to make use of the formula root of a1 square plus b1 square. And if you need second harmonics, you have to calculate root of a2 square plus b2 square, and so on. Now here it's written 0 to pi, so you will be getting problems for 0 to pi and 0 to L also. In the case of 0 to L, if suppose you have an interval called 0 less than or equal to x less than or equal to 6, okay, then how will you find the length of the interval? 6 minus 0, and then you need to equate that 6 with interval 2L. 2L equal to 6, L will be 6 by 2, which is 3. Okay. So if you have 0 less than or equal to x less than or equal to 8, then you have to get 8 minus 0. So length is 8 minus 0 equal to 8, and then you need to equate that 8 with 2L. 2L equals 8, then L will be 8 by 2, which is equal to 4. So, we will be getting problems for 0 to L. For 0 to L problems, you have to equate the length with 2L. And 0 to pi problems, you will be taking the values as given in the values of x and y. Belongs to the table. Okay? Let's get into problem. Express f of x as Fourier series up to second harmonics for the given table. Now from the table, you can see values of x are 0, pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3 and 2 pi. Now just notice the first value and the last value. First value of x is 0 and the value of f of x or y is 1.0. And what about the last value? Last value of x is 2 pi and f of x value is 1.0. So here you can see the first value and last values are the same. So if you have a repeated value, since it's a periodic function, your value repeats at the end. Okay? So here you can see f of 0 and f of 2 pi values are same, which is 1.0. Whenever you have the same value, you need to exclude the last value, because last value is same as the first value. So when you exclude the last value and you give a count, so what is the count starting from x? 1, 2, 3, 4, 5, 6. Here value for n will be 6. Value of n is not 7 because last value is 1.0, which is a repeated value. So whenever you have a repeated value, you are supposed to exclude the last value. So n will be 6. Okay. So the values of y equal to f of x are spread over the interval 0 less than x less than or equal to 2 pi. So you can see that f of 0 is f of 2 pi equal to 1.0. It's a periodic function. Okay, value repeats at the end and the repeated value you are supposed to exclude. Hence the function is periodic. So we'll exclude the last value. Hence value of n when you count from 0, 1, 2, 3, 4, 5, 6. Excluding the last 2 pi value, value of n will be 6. Now how to get A0? A0 formula you have already written. It's 2 summation y by n. What is the value of n? N is 6. So what's 2 by 6? 2 by 6 is 1 by 3. So here I have written divided by 3 and summation y is sum of all y's. Add all the y values, you will be getting 8.7 divided by 3, which is 2.9. A1 value is got by writing 2 summation y cos x by n. Again n is 6, 2 by 6 is 1 by 3 and each value of x varies from 0, second value of x is pi by 3, third value 2 pi by 3, then you have 4 pi by 3, then you have 5 pi by 3. So replace all x values from beginning to end, not the excluded value, other than excluded value. No last value will be included because last value is same. Okay, and each value of y values are 1, 1.4, 1.9, 1.7, 1.5, 1.2. So put all the numerical values and do the calculation in a numerical way. Add, finally you will be getting minus 0.3667. To get A2, 2 summation y cos 2x by n. Again put n equal to 6. 2 by 6 is 1 by 3. And cos 2x. Replace all x values starting from 0 and ending with 5 pi by 3. Then 2 times of that. 2 times of x values. And y into those values. Sum all the values and divide by 3. You will be getting minus 0.1. And b1 value, do the calculation using summation y sin x by n. So here you need to calculate sin of all x values. Replace each x values, sin of that value and all y values. Then sum those y sin x values. Okay. Then b2. b2 is 2 summation y sin 2x by n. Put all values of x. Again calculate sin 2x, then y into sin 2x, summation of those values. Okay. Using calculator you can find all these values easily. Put all the numerical values with much care. Hence f of x equal to, you have written the formula, substitute all the values in those formula, you will be getting an answer. Next problem. Y is a Fourier series up to third harmonics. So third harmonics in the sense you have to go till A3, B3. Okay. Then here have a look at those values 0, 1, 2, 3, 4, 5. So these are 0 to 2L problems. You can see the numbers displayed here. Right now we have seen 0 to 2 pi problems. This is 0 to 2L problems. Now 0 to 2L, how will you consider interval here? Your value is still 5. So you can write it as 0 less than or equal to x less than 6. Values are till 5 and remember we have to equate it with the 2L. Okay. Now let me put a point over here. Suppose you have a number after 5. What would be that number? Number will be 6, right? Because these are equidistant, you can see 0, 1 after 1, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5. Equidistant values of x. Okay. Now if you have the next number will be 6 and the value for y will be the repeated value which is same as 4. It's a periodic function. So if a value repeats, that value will repeat at the end. Okay, and you will be having x as 6 and y as 4. So what will you do? What will you do if you have a repeated value? What's the procedure? If you have a repeated value, you are supposed to exclude the last value. So if I have 6 and 4, you will be excluding the last value, right? And how will you count n? 1, 2, 3, 4, 5, 6. N you will be writing as 6 and not as 7. Now without 6 also the value of n is same. See 0, 1, 2, 3, 4, 5. Count 1, 2, 3, 4, 5, 6. Here n is 6. So if you have another value, next value after 5, then you will be excluding the last value because that will be a repeated value. And the value of n is same as 6 and not 7. Now here the interval length you are supposed to compare with 0 to L. So 0 to L will take it as 6y. As I said, 0 to 5 interval length will be 0 less than or equal to x less than 6. I have explained this right now. So length of the interval is 6 minus 0, 6, and I told you, you have to compare the length of the interval with the 2L equal to 6 and L will be 6 by 2 which is 3. Now, for real series up to third harmonics, the formula will extend till A3 as I told you. So, y equal to A0 by 2 plus A1 cos theta plus B1 sin theta plus A2 cos 2 theta plus B2 sin 2 theta plus A3 cos 3 theta plus B3 sin 3 theta. Now, what's theta? Where theta we'll consider as pi x by L, and we got the value of L as 3. Put pi x by 3. So, these are for 2L problems. The calculation we are doing it for 2L problems. 2 pi problem we have seen. Okay. Now, A0 formula will be 2 into summation y by n. Okay. And what's that? N value is 6. L value is 3. N value means the count which you have started from 0 and you're ending till 5. So, count was n equal to 6. 2 by 6 is same as 1 by 3, and sum up all the values of y, you'll be getting 14. Now, go for A1. Go for A1. Second one. Yeah, the similar way. Cos theta. What is theta? Pi x by 3. First value of theta. X is 0. When x is 0, you will be getting cos 0. Second one, pi x by 3 means pi into value of x is 1. So, you will be getting pi by 3. Then, pi into next value, put x equal to 2 pi by 3. Like that, you are supposed to put value till 5. Now, go for the numerical calculation. You will be getting the value of A1 as minus 2.8333. Next, go for A2 calculation. In place of cos theta, you have cos 2 theta. So, put the value of theta as pi x by 3. Replace using each values of x and cos 2 into pi x by 3 into y. Sum up all the values. Divided by 3, 2 by 6 is 1 by 3. After calculation, you will be getting minus 1.5. Similarly, A3, B1, B2. Values are 2.667 for A3 and 4.3301 for B1 and minus 0.8660 for B2. Now, B3 calculation yields 0. Then substituting the values in y, so you are getting numerical values. Harmonic analysis is obtaining the values numerically. Y equal to A0 by 2, then put all the values A1, B1, A2, B2, A3, third harmonics problem, right? So you put the values till third harmonics and obtain. Replace all theta values by pi x by 3. This is the numerical answer. So let me wind up my session. Thank you.